Hello, hello, hello. What's up, everybody? Everybody, what's up? Good morning, and welcome to the PYQ, not PYQ, CYQ session, right? And every day we are meeting at 6 o'clock in the morning and doing 12, 11, 10, 13, whatsoever. Okay? Most expected question basically. So we are doing most expected question from that chapter. Okay? So we are balancing it out. 2 days physics, 2 days chemistry, and finally 2 days mathematics. I just want to check. In fact, I just want to ask all of you, just confirm, give me a green signal whether I am perfectly audible as well as visible. Hi Sabri, how are you? On time, always on time, okay? So make sure the moment you enter the session, you smash that like button, because early morning we are smashing. Early morning we are setting the intention and starting the day with 11, 12 questions, right? So this is going to be a major confidence boost for the day, okay? Right? All right, I can see. Good morning, Sabri. Good morning, Shri Devi. Good morning, everyone. All right, all right. Okay. You know what? I would say binomial theorem. Let's talk about this chapter first before we dive into question part. Let me tell you about binomial theorem. I always feel that binomial theorem is one chapter every JEE aspirant should do. Okay. You must be thinking, but ma'am, why binomial theorem? This is not even highest weightage. There are more high weighted chapters than binomial theorem. Okay. So why binomial theorem? Because you know what? This is a high weighted chapter. That means two short questions, 1 to 2 questions. So every year we see. Okay. Almost 2 questions in every shift. In some shift you can see 1 question as well. But yes, on an average 2 questions I would say you can see in every shift. Okay. Now one more important thing of binomial theorem is this chapter has almost no prerequisite. Okay. So this chapter, to complete this chapter or to dive into this chapter, you don't have to study any other chapter. But this is not the case with other chapters. If I talk about other chapters like definite integration, differential equation, they do have some prerequisite, okay? So, you know what, and 3D geometry also, you have to do straight lines before 3D geometry. But this chapter, okay, this very chapter is going to actually give you most, like, I think, rewarding chapter, I would say. Okay. All right. Yes, Ramu. Yes, ninja techniques we are going to actually do in this chapter base. And one more thing, you know what, this chapter has, I think, maximum number of ninja techniques. Okay. All right. Yes, summation of coefficient is hard, series based, everything we are going to see. Chalo, let's see. First of all, let me reveal that what are the must do subtopics from binomial theorem. Okay. So clearly term independent of x is something every year you are seeing this a question on term independent of x, or you can say constant term. Okay. Then rational / irrational terms, number of rational terms, number of irrational terms, correct? Property of binomial coefficient. Now there are so many properties of binomial coefficient that I am going to give you in the next slide. And remainder problems. Okay. So remainder problems, so clearly ninja technique is going to help. All right. Yes. Now let's talk about properties of binomial theorem, or rather I would say let's quickly like revise quickly, like 1 minute revision of binomial theorem, and we are going to dive into question parts. All right, everybody. Yes. Okay. Now let's see clearly, whenever you have x plus y power n, okay, the formula of general term everybody should know. I think 50% of binomial theorem problems are based on this formula, which is TR plus 1 is equals to NCR x power n minus r and y power r. Okay. All right. So this is general term. Now the same expression, if at all you are getting this 1 plus x power n. Okay. So general term of this expression will be NCR x power r. What does that mean? What does that mean, everyone? What does that mean? So here we can say that in the expansion of 1 plus x power n, the coefficient of x raised to power r is nothing but NCR. So if I ask you what is the coefficient of x power 10, you'll be like NC10. Okay, I hope you're getting it. Now let me talk about this. Okay, sum of all the binomial coefficient NC0 plus NC1 and all the way up to NCn is nothing but 2 power n. Everybody should remember this property, right? NC0, NC1, NC2, NC3 is nothing but 2 power n. Okay. So if at all the signs are positive, 2 power n. But if at all alternate plus minus sign, if you can see plus minus, so the answer is going to be 0. Okay. Now again, if you are only going to write the even index NC0, NC2, NC4, the answer will be 2 power n minus 1. And you know what? Even if you write just odd index NC1, NC3, NC5, then only your answer will be 2 power n minus 1. I hope these properties are sorted. Give me a good thumbs up. Okay. Yes. All right. Now this property, very important property. NCR minus 1. So basically what is happening over here is both n are same, but there is a gap of r minus 1 over here. So it will be what? N plus 1, and the greater of these two is r, so r is right here. Okay? Yes? Clear? Now let's talk about this. This is very important, and you know what? This is going to be reducing the number of steps also. Okay, what is this? NCR upon NCR minus 1. Basically, both n and r same, but r and r minus 1, there is a gap of 1. So the final answer will be what? N minus this. Can you see? N minus denominator lower index. N minus denominator lower index. Can you see? So this is n minus this is written over here. Okay, and r is written over here. Don't worry, one by one, whenever problem arrives, now I will recall it. Okay, and this is the most underrated property and my favorite property. Finally, last property, NCR. Whenever you see NCR, okay, NCR, now you know what, this n and r will be right here. So n in numerator and r in denominator. NCR is n by r, and you just have to reduce 1 to get the final answer. Okay, all right, okie dokie. Now what we are going to do is we are going to start the very first question of the session, right? Ready? Ready for the first question? Quickly. This session is going to be very quick because we have got a lot of ninja techniques as well. Okay. So what we are going to do is we are going to quickly dive into question part now. And before that, I hope if you are joining our channel for the very first time, make sure that you're subscribing, because this channel is going to be the door or gateway of your JEE Main 2026, okay, and 2027 as well. All right, so this is my credentials, and you know that Ninja Ma'am is going to give you ninja techniques so that you can save loads and loads of time in some question, and you can actually reward something to difficult questions. Good to go? Yes, first question, everybody, and make sure you are actually downloading Ved AI. I don't have to tell you, right? Ved AI, okay. Everything is like automated. Chalo, let's start. Okay, let's start, right? Okay, all right. This question is talking about term independent of x. Term independent of x. Okay, term independent of x. So now this is the binomial expression, correct? So n over here is 12. So I am going to write the general term tr plus 1. Everybody, tr plus 1 is what? 12cr. Then the first x by 4. X by 4 power what? Just applying the formula. 12 minus r. Okay. And minus 12 by x square power r. Okay. All right, general term. Now we are looking for independent of x. That means the power of x should be 0. So power of x, everybody, power of x is what? Power of x, ma'am, from here is 12 minus r, and this is going to be minus 2r. So 12 minus r minus 2r should be 0. Clearly, 12 is equals to 3r and r is going to be just 4. The moment your r is 4, correct? Now you just have to plug in the value of r over here. X will definitely vanish. So your answer will be coefficient. The final answer will be what? 12c4, correct? X is anyway gone. So this is 1 by 4 power 12 minus 4. 12 minus 4 is what? 8. And you know what? This is minus 12 power what? Where are you? 4. Yes. Okay. All right. Independent of x means maximum numerical value. Who said that? Why are you creating your own definition? Independent of x means independent of x. Independent of x means x power 0. Right? Okay. So this is going to be your answer, everyone. Right? Now we just have to do the calculation and we are good to go. Okay. Good to go. So 12c4, everybody, 12 into 11 into 10 into 9 upon 4, 3, 2, 1. And this is going to be what? 4 power 8. So this is going to be 4 power 8 over here. And 12 power 4 is what? 3 power 4 and 4 power 4. Okay. All right. So this is going to be 4, 3 and 12 are getting cancelled out. And this is 4 power 4. This is 4 only, right? 3 by 4. And you know what? As per the question, they are giving 3 power 6. So this is 3 power 6 upon 4 power 4. K. Okay. Term independent of x, they are already giving, which is this. Okay. So now all we have to do is 4 power 4 and 4 power 4 is gone. Now 3 power 4 and this 3 square. So this is 3 square. 3 square and 9 are again getting cancelled out. So K is coming out as clearly 55, my dear students. Option D is absolutely right. Okay. All right. So term independent of x. A short question is going to be there. Same question. Okay. In JEE Mains 2026. Let me tell you. But in which shift? I am not sure. In how many shift? I am not sure. But short question will be there. So be prepared. Now one question I am going to give you as homework. Okay. Similar question. I hope that you are going to honestly do this question if you are serious about JEE Mains. Okay. If the constant term in the expansion of this is given and you need to calculate the value of 25 alpha, similar question. Constant term and term independent of x, exactly same question, two different scenarios. Okay, done and dusted. Give me a good green signal that ma'am, yes, we are going to do, and we are going to let you know the answer in the comment section. Okay, let's move forward and tap the another category over here. Okay, so in some questions what they do is they talk about ratio. Okay, ratio of the two coefficients. Okay, so let's deal with these type of questions as well. Let's understand how to handle this. M and N be the coefficients of 7th and 13th. Okay, 7th term we are looking for. So T7 will be T6 plus 1, correct? 18. So T6 plus 1, again general term formula, 18C6. Okay, then we have 1 by 3. X power 1 by 3, it is going to be 18 minus 6. So it is going to be 12, n minus r, 18 minus 6. Okay. Then we have 1 upon 2 power x, 2 by 3. And we are having over here, this is just 6. So this is T7. Okay. Similarly, T13, my dear students. T13 is nothing but T12 plus 1. Correct? T12 plus 1, TR plus 1 is what? 18C12. Correct? And this is 1 by 3 power x by 3, 18 minus 12, 6, and 1 by 2 power x, 2 by 3. This is going to be 12. Okay, all right, correct. Now what they are saying is m and n are the coefficients, right? M and n are the coefficient of 7th and 13th term, correct? So that means we are not interested in x, we are interested in coefficient. So this will give me m and this will give me n. And I am looking for n upon m. So n upon m, my dear students, will be what? This is n. 18C12 upon 18C6. And you know what? 18C12 and 18C6 both are same only. I hope you know. NCR, NC, N minus R, okay? Now again, 1 by 3 power 6, okay, and 1 by 2 power 12. Here 1 by 3 power 12 and 1 by 2 power 6. If you're going to solve, what are you going to get is 1 by 2 power 12, okay? So eventually 1 by 2 power 12, and this is, sorry, 1 by 2 power not 12, 1 by 2 power 6 and 1 by 3 power 6, okay? So this is 3 by 2 power 6 eventually. So 3 by 2 power 6, okay? 3 by 2 power 6 is nothing but n upon m. Okay, now you're looking for power 1 by 3. So 1 by 3, both the sides if you take, you're going to get what? 2. So this is 9 by 4. Easy peasy lemon squeezy. Now, please make sure my dear students, that you are letting me know that whether it is an alpha question or beta question in the chat box. Yes, I can see Sabrito is every time giving me answer as well. Yes ma'am, 9 by 4. Okay. Yes, 9 by 4 is correct. This is, I feel, not a very difficult question. Okay. Good to go. Give me a big thumbs up. Okay. Let us move on to the next category question now, which is talking about, okay, let's actually stay in this category only. Okay. Okay, let's do this. Write this question. Okay, all right. For some n not equal to 10, let the coefficient of 5th, 6th and 7th terms in the binomial expansion of this be in AP. Okay, so 5th, 6th and 7th terms are in AP. What does that mean? That 2 times T6 is equals to T5 plus T7. This is how the condition of AP works, right? 6th term, double of the middle term is equal to sum of extreme. Now T6, be very careful, huh? Sometimes people what people do is T6 is what? T5 plus 1, okay? So here n plus 4 C5 and this is going to be n plus 4, right? N plus 4 C4 plus n plus 4 C6, okay? Now obviously one way is just open it, okay? And eventually keep on cancelling term, but this is not how we are going to do that, okay? Ninja ma'am is here. Some little ninja trick the ma'am will apply over here. What we are going to use is n CR upon n CR minus 1. Do you remember this property? Okay. N minus lower index of the denominator, so n minus R plus 1 upon this R right here. So let's use this property. But ma'am, to use this property, we need a ratio. Here, I can't see any ratio. Let me show you. See, divide this whole equation by n plus 4 C5 to get the ratio. Okay. Alright, so this is gone. 2 is equals to, let me write. 2 is equals to, now see. This is what? N plus 4C4 and N plus 4C5. Basically reciprocal of this. Okay, so again I am going to write reciprocal over here. So this is going to be what? N minus this, correct? So this is N plus 4 minus 4. So N plus 4 minus 4. And you know what? This 4 will sit over here. Okay, reciprocal we have applied. If you're not getting, you will get it now if I'm going to apply the property over here. Can you see this is matching? R minus 1. So 6 and 5, correct? Now N plus 4 minus 5. N plus 4 minus 5 upon this 6 right here, 6. Okay? Yes, I hope that it is visible. If not, I'll make it visible. Yes, this is how it is. Okay? So clearly your equation, let me write the equation over here. Clearly the equation is 2 is equals to 4 by n plus n minus 1 by 6. So now if you're going to solve this, you are going to get a quadratic equation. Let's solve it. So this is going to be 12n. Okay, 6 4s are 24, and this is n square minus n. Okay, plus. Yes. So it is going to be what? N square. Correct? N square, and it is going to be minus 13 n plus 24 is equals to 0. Yes, is this what I am going to get? 2 is already there. Okay, and this is 4, this is 6. Okay, or maybe hold on, this is 13n. N minus 1, correct? Or else, see, the value of n, if at all it is 3. So 4 by 3 and 1 by 3. 2, 1 by 3, 4 by 3, 5 by 3. Have I done any mistake? Ma'am, the numerator it is 5. Okay, maybe, yes. So from here, yes, over here I think this is 5. Yes, this is 5. Okay, so this is where I made a mistake. This is 5. Okay, anyway, now if you're going to solve this, the quadratic equation you're going to get is nothing but, let me tell you, n square minus 11n plus 30 is equals to 0. Clearly, n is coming out as 3 comma 10, right? 3 comma 10. So this is going to be 13. Yes. 3 comma 10. Clearly, 10 is not the answer. So n is equals to 3 will be accepted. Okay. The moment your n is 3 now, if n is 3, so 1 plus x power 3 plus 4, 7. The largest coefficient in the expansion of this. So largest coefficient now. See, now the largest coefficient. 7CR will be the coefficient, and the largest one will happen when R is the middle of 7. Like R is half of 7. So R should be 7 by 2, 3.5. But ma'am, 3.5 cannot be the value of R. So either 7C3 or 7C4, both are same. So both will work. 7C3, 7C4. So 7 into 6 into 5 upon 3, 2, 1. Okay, so this is going to give you 35. Option B, absolutely correct. Okay, yes. Yes, everyone, getting it clear? Okay, so I think this property is going to make your calculation slightly on an easier side. Yes? Okay, getting it? All right. Now let's talk about another question on your screen, which is again based on the summation property. Very good property, okay? So over here, n is greater than or equals to 2 and is a positive integer, then the sum is this, okay? Now let me tell you the proper method to solve this question, and let me give you ninja technique to solve this question within 10 seconds, within 5 seconds in fact, okay? So first, let us learn the technique, okay? Because you know what, you will be like, ma'am, why to learn the technique? Because you know what, sometimes you can't get a question in MCQ type, same question if you are going to get in numerical type, no, then ninja technique will not be applicable in this case, which I'm going to tell you, okay? So let's just first learn the technique, be a good student and learn the traditional method and don't go behind the shortcut, okay? Yes, but still keep shortcuts in your pocket. Whenever it is applicable, you're free to apply. Okay. All right. Now the moment NC1 plus 2, this is 2, and this is what we need to figure out. 2C2 plus 3C2 plus 4C2 plus 5C2 and so on. Now this particular thing is very popular. You have to do a little manipulation to get the answer correct, okay? So 2C2 is what? See, you know NCN is what? NCN is 1. So this 2C2 actually I can remove and I can write what? 3C3 as well. Correct? Now 3C3 plus 3C2. Remember? See, 3C3 plus 3C2. Tell me what will be the value. Remember the property NCR plus NCR minus 1 is nothing but N plus 1 C maximum of these two. Same. 3, 3, same, gap of 1. So this is 4C, maximum of these two is 3. Okay. So I think these two will get combined and you're going to get what? 4C3 in place of this sum. Correct? Now can you see this 4C3 and 4C2? Again, 4C3 and 4C2 are going to get combined and you are going to get 5C3 instead. Are you getting my point? Yes. And after that you have 5C2. Now again these two will get clubbed together so that you can get 6C3. Okay, 6C3. And now it will keep on continuing. Right? The moment you will reach NC2, so you are going to get NC3 ready. NC2 plus NC3 in the end will become what? N plus 1. Finally, you are going to get N plus 1 C3. So now you have your thing will be what? N plus 1 C2 plus 2 times N plus 1 C3. That's it. Just open it. You are good to go. Okay. So let's see. N plus 1 C2 will be what? N plus 1 and N C2. So this is 2 into 1. Plus 2 times N plus 1 C3, N plus 1, N minus 1, 3 factorial is what? 6. So this is just 3. Now clearly N and N plus 1 I can take it out. Okay, and this is going to be 1 by 2 plus this is N minus 1 by 3. So just solve it. You're going to get N plus 1 by 6 and this is 3 and 2N minus 2. Okay. So 2N minus 2 and this is plus 3. Minus 2 plus 3. Minus 2 plus 3 is plus 1. Correct? And that's it. Okay. So let me check. Option B is absolutely correct. Okay. Yes. All right. Correct. Okay. Now you must be thinking, ma'am, okay, fine. We've got the answer. Right? We've got the answer. You were talking about some ninja technique. Are you going to tell us or not? See, ninja technique is actually not a not a ninja technique. It is a common, obvious thing. In fact, somebody who is not aware of binomial theorem chapter can also do this question. Okay. All you have to do is hit and trial as per the options. Okay. So put n is equals to 2 because they are saying, no? So let me put n is equals to 2 and calculate the answer for a specific n. So if n is 2, clearly this is going to be 2 plus 1, so 3C2, right, plus 2. And if n is 2, then you know what? The summation goes up to just 2C2 only. Okay, there will be just one term in the summation, 2C2. Your answer will be what? This is 3 plus 2 and this is going to be 5. Okay. The moment your n is 2, this whole expression is becoming 5. Okay. Now you start putting the value of n as 2 in each and every option. Whatever option is giving you 5. Okay. Alright. Whatever option is giving you 5, it will be your answer. So n is equals to 2, ma'am. So this will be 2. 2 minus 1, 1. And this is 2 to the 4 plus 1, 5 by 6. No, ma'am, this is not getting. So A is wrong. Okay. 2. So 2 and then 3 and then this is 2 to the 4 plus 1, 5 upon 6. Can you see clearly that option B is giving you 5? That's why option B is absolutely right. Okay. All right. Good technique. Yes. So this can be actually applied in 2 chapters. Mostly 2 chapters. Binomial theorem and sequence and series. Remember, whenever your summation is generic and your options are also given in terms of n, you can apply this technique. Right? Okay. Which 2 chapters? Sequence and series and binomial theorem. Specific technique is mostly applicable in these 2 chapters only. Okay. All right, everyone. Yes. Okay. Now, another question on your screen is this. Another question, yes. Again, ratio of coefficients will be required over here. Okay. So let's see. sum of the coefficient of 3 consecutive terms in the binomial expansion of this. 3 consecutive terms. So let us assume now 3 consecutive terms. Let us assume TR plus 1, TR plus 2. Okay. And the coefficients, tell me, coefficient will be n plus 2 CR minus 1, n plus 2 CR, n plus 2 CR plus 1. Okay. And the ratio is given as 1:3:5. What I'm going to do is I am going to pick these two. N plus 2 CR whole upon n plus 2 CR minus 1 is equals to 1 by 3. Okay, sorry, 3 by 1, right? Please make sure that you also do not do this silly mistake. Did you see that what was about to get happen? I was like this upon this, and ratio will also be 3 by 1 now. Why were I writing 1 by 3? Okay. So now again, can you see that shortcut? N plus 2 minus R minus 1. So n plus 2 minus R minus 1 whole upon R is nothing but 3. Okay. So this is going to give you n plus 3 minus R upon R is equals to 3. This is the first equation, correct? Now similarly, what we are going to do is we are going to apply this n plus 2 CR plus 1 upon n plus 2 CR is 5 by 3. Again, same property I am going to apply, n plus 2 minus R, okay, upon R is 5 by 3. Second equation. Now please understand, two equations, two unknowns. Two equations, two unknowns. Can't you solve this question? Tell me what is the value of n and R. Just solve this. Okay, n is equals to 5 and R is equals to 2. This is what you're going to get if you're going to solve this. Just cross multiply and solve, nothing else. Okay, n5 and R2. Yes, n5, R2. Now what they are asking, sum of the coefficient of 3 consecutive terms is equal to what? Now sum of the coefficient is what you're looking for, okay? So basically you're just looking for sum of these three things. 5 is there. So this is what? 7C, R is what? 2, correct? So 7C 1 plus 7C 2 plus 7C 3 is what you're looking for. Again, you can apply that property. So this is going to give you 8C, okay? Or rather, let's apply this property in the last two. Yes. So this is the anyway 7 now, plus this is 8C3. Okay, so 7 plus 8 into 7 into 6 upon 3 into 2 into 1. Okay, so it is 6 8s are 48. Sorry, 7 8s are 42. 42 plus 7. 42 plus 7 is 49. 7 8s are 56. 56 plus 7 is what? 56 plus 7 is 63. Yes, 63. Option A is absolutely correct. Okay. Yes. Are you getting it? I feel that this session is actually very good. While solving it myself, I feel that I think each and every part will get revised also. It's not just most expected, but you are revising a lot of things in here. Okay. And now let's switch the type. Okay. And let's talk about number of rational and irrational term. And you will get ninja technique. Okay. So number of rational terms whenever they are asking, okay, rational term will be nothing but 120 upon LCM of, okay, first of all, right now you can't apply the ninja technique because ninja technique is applicable when these two are prime numbers. Right now 4 is not a prime number. So let's convert, this 4 will be 2 square. So can I just write 2 power half plus 5 power 1 by 6? Now you can apply ninja technique. Okay, ninja technique says that okay, 120 is there upon LCM of 2 and 6. LCM of 2 and 6 is 6 and GIF plus 1. That's it. Okay, so this is going to be 20. 20 plus 1, 21. Easy peasy. Option A is absolutely right. Okay. All right. So number of irrational terms. Do you want one more question? One more question on your screen. Okay. Now this time they are talking about number of irrational terms. Okay. The procedure is same. Let's first calculate number of rational term and then we are going to subtract from the total terms. Okay. So again, can you see 3 and 5 prime numbers? Yes, good to go. We can apply. So this is 60 upon 4 and 8. LCM of 4 and 8 is 8. Okay. And you know what? You have to take the GIF. Alright. So this is going to be what? This is 4. This is 30. In fact, 15 by 2. 15 by 2 is 7.5. So this is just 7. Okay. Now plus 1. To do or not to do. See, this time, you know what? This thing is not coming in integer. Whenever this is not coming in integer, then answer could be 7 or it could be 7 plus 1. But how will we decide whether the answer will be 7 or 7 plus 1? Okay. So for that, all we have to do is just, just write the first term. Basically, r is equals to 0. T1 we have to write. T1 will be what? 60 CR. Okay. And then it is going to be 3 power 1 by 4 and 60 minus r. 60 and you know what? 5 power 1 by 8 power 0. Basically, all you have to do is you have to find 60 by 4. 60 by 4. Tell me, 60 by 4 integer or not? 60 by 4 integer or not? Yes. 60 by 4 is an integer, right? So, it is going to give you what? Integer. So, that's why you have to do plus 1. So, 8. 8 rational terms, correct? 8 rational terms. So, if there are 8 rational terms, so how many irrational terms then? Irrational terms is equals to total minus 8. Okay. How many total terms? How many total terms? In the chat box, can anybody tell me how many total terms? I am taking a pause. How many total terms? 60 or 61? So many students do it wrong. Okay. So 60 minus 7, it is going to be 53. Yes, 53. Now 53. Okay. N is the number of irrational terms. So this is 53 minus 1, 52. 52 is divisible by 26. Option D. Okay. Give me a big thumbs up if you are understanding this. Good question, I think. Can you see how these two beautiful questions are designed? Number 1 question, easy peasy to understand the ninja technique. And number 2, if at all they are giving some twist, you should be prepared. Okay. All right. So this is number of irrational terms. So many questions done from my side from this category as well. Okay. All right. And now we are going to talk about remainder problems. Remainder problems, my dear students. Okay. Ready for remainder problems? Okay. And then we are going to talk about properties of binomial coefficient. Alpha question. Yes, Sabri. Okay. All right. Also, I'm not sure whether you're liking my session or not. Yes? Liking the session? All right. Remainder theorem, again ninja technique we are going to apply. Okay? Yes? So, let the number 22 power 2022. Leave the remainder alpha when divided by 3. Okay? So, in here, what you have to do is, please understand, ma'am, will you do this for 2027 also, please? Absolutely. Why not? Huh? When we were doing these type of sessions for 2025 aspirants, 2026 aspirants used to ask the same question. Okay. And you know what? This is the living proof. We are doing it for 2026. So we'll do it for 2027 as well. Okay. All right. And every year we are also becoming better version of ourselves. Okay, Vedantu JEE English as a team I am talking about. Okay, so yes, now please understand, if you want remainder when the expression is divided by 3, okay, all you have to do is you have to go with the base. Okay, understand, alpha. So remainder when this expression is divided by 3, how to do that? Focus on the base, forget about the power for the time being. What happens, tell me, when you divide 22 by 3? Everybody? So ma'am, 22 if you divide by 3, so 7 3s are 21, ma'am, 1 remainder, okay? So this is going to be 1 power 2022, so 1 will be this plus. Now this, can you see 2022? This 2022 itself is a multiple of 3. Multiple of 3 power something when divided by 3 will give 0 as the remainder. That means alpha is coming out as 1. Okay? Yes? Now beta. Beta is talking about when divided by 7 again. 7 and 22, whenever you divide, 7 3s are 21, again 1 is the remainder, plus 2022. Okay? 2022 and 7. So now you have to find a number. Okay, a number which is near to 2022 and if you divide by 7. Okay, so clearly let me tell you, 2023, if you divide by 7, you're going to get remainder 0. 2023 is divisible by 7. So if you divide by 20, minus 1 will be the remainder, right? Minus 1, 6 basically, but minus 1 will be the remainder. Minus 1 power 22, it is going to be plus 1. So beta is coming out as 2 in that case, 1 and 2. So 1 square plus 2 square is going to be what? 5. So option D is absolutely correct. Okay. All right. Yes. Now let's talk about another question again based on remainder theorem. Okay. All right. Slightly difficult. Slightly difficult. See, one easy question, one difficult question, so that you also understand that I can do it and I should not be overconfident as well. Okay, there can be some question which might be slightly difficult. Okay, so now in here what I'm going to use is, see, understand. Suppose you have 1 plus x power n. Okay, 1 plus x power n. Tell me, 1 plus x power n is what? nc0 plus nc1x plus nc2x square and so on. Correct? nc0 is what? 1. nc1, so this is nx plus n minus 1 x square by 2 and so on. Okay? Alright. If at all, x is an integer. Okay? So what I'm trying to say is 1 plus. Can you see every term after this is having x? So can I write this as x? And you know what? After x, so this is an integer. See, x if you take common, what will you have? You will have integer only. So basically xi. Okay, xi. 1 plus xi. Can I write this? Can I write this? Let me tell you. See, you don't have to open it as well. What I'm trying to say is that nc0, except nc0, every term will have x square x. If I can take x common, okay. Now, inside this, what is going to be there? If your x is an integer, na, NCR is anyway integer, x is integer, so this is going to be an integer. So basically 1 plus x power n is going to give you 1 plus xi. Yes or no? Can I write? Okay, this is absolutely important. Especially when you are going to get stuck in remainder problem, na, this is going to be your key. Okay. So over here, 3 into 7 power 22, this is when divided by 18 is what they are writing. Okay. So 18 I am looking and 7 power 22 I am looking. Okay. So 7 can be written down as 1 plus 6. Yes or no? So this is 3, 1 plus 6 power 22. Okay, plus 2 times, this is 10. Okay, 10 and again 18. So I can write 1 plus 9 power 22 minus 44. Yes, can I do that? Now what about this? 1 plus x power n is nothing but what? 1 plus 6i plus this 2 times I1. This is 2, 1 plus 9i2. Okay, minus 44. I can write like this. Okay. Now understand, this is what? 3, 6 3s are 18. Okay. So this is 3 plus 18, multiple of 18. 3 plus multiple of 18. So basically, if you're going to divide this expression, see, if you're going to divide this expression by 18, you are going to get this. And if you're going to divide this expression by 18, you're going to get this. So this is what? 3 plus 18 something. So what will be the remainder? 3 will be the remainder. So 3. 3 from here, similarly 9 2s are 18. So this is anyway divisible. So 2 will be the remainder from here, and minus 44. If you're going to solve this, 5 minus 44, 39 with a negative sign. Okay. Minus 39 can never be the remainder. So you know what? Now what you can do is plus 18 into 3. 18 into 3. 8 3s are 24. And 3 1s are 3, 54. So plus 54 we have to do. Okay. So 54, it is going to be what? 10 plus 5, 15 will be the answer. 15, where are you? Option B. Okay. Slightly lengthy. Have a look. You know what? You might be thinking, ma'am, but this is too tough when I don't know. I mean, so many steps. But you know what? Solve 3-4 questions and come back. You'll be like, now the things are pretty clear, ma'am. Every question is having same thing. Because it was the first question. That's why I was getting stuck. Okay. So remainder theorem, make sure you're practicing at least 7 to 8. Go for 10 questions as well. Okay. If at all you're not feeling confident. But make sure you do that so that you get the better understanding and you can solve all variety of problems. Okay. Now we are going to talk about this question. Last two questions. Last two questions, my dear students. Ready, ready, ready. And you know what? These two questions are based on my favorite property, which is most underrated property. Okay, let me tell you, I have showed you in the beginning also. What is the property? NCR is N upon R, N minus 1, CR minus 1. This is the property which we are going to apply. Okay, alright. So now I can clearly see that this question is having two things. This is another dimension, another parallel universe is going on over here, 14C3, 14C5, okay. And this is something, not even this, including this, yes, this is another thing and this is another thing. So basically this is two different series are going on. Let us focus on this one, okay. Do you remember in the beginning I told you all the odd indexes, NC1, NC3, NC5, and last it should be 14C13 is missing over here. Can you see? So if you add 14C13, your series will get completed minus 14C13. Okay. So now this is your completed series. So this green box is going to be 2 power n minus 1. So this thing is nothing but 2 power n minus 1. 2 power n minus 1 is 13 minus this, the 14. So this is the second series. Okay. This is the second series. Okay. Now what about this? So ma'am, this is minus 15C1 plus 2 minus 3. Okay. Alternate things are going on. So one thing, let me just write this part in the form of summation. General term I am going to write. So minus 1 power r 15CR. Can I write in this manner? In fact, r is also there. Okay. So this is minus 1. This is what? So it general term I am writing. Minus 1 power r. Then we have r and then we have 15CR. Sigma r starts from 1 to the last term is 15. Everybody, yes? This is what we have to figure out. Okay. Correct? Right? Now, again, R. So now understand. Whenever you see there is NCR and there is some number is getting multiplied with R. Okay. Sabri, what are you saying? Ma'am, n minus 1 na. Then it is 12 na, ma'am. How 13? What is n? N is 14. This is n, right? N is 14. Okay. Anyway, come back. See. So, whenever you see NCR is getting multiplied with R or R square, this most underrated property, please remember. Okay. So, I am telling you when to apply. When to apply this property? Whenever you see NCR is getting multiplied with some other constant and sigma is also there. Okay. So, I am going to apply this. So, this is going to be sigma R is equals to 1 to 15 minus 1 power R. This is already R. Now, 15 CR is what? 15 by R and 14 CR minus 1. Okay. So, R and R is getting cancelled out and now you are going to have 15 will come out. 15 sigma R is equals to 1 to 15 minus 1 power R 14 CR minus 1. If you are going to open this, now understand, if you are going to open this, put R is equals to 1. So, it is going to be, the moment you put R, minus 14C0, then plus 14C1, minus 14C2. Do you remember? This alternate thing is happening. 15 will get multiplied. So, this is going to happen, which is nothing but 0. That means this summation, this thing, this series is giving 0. Okay. So, only this part will be remaining, which is having, anyway, we have sorted this out in the very beginning itself. The answer will be option B. Okay. All right. So, this is something which is going to be definitely there in JEE Main 2025, and I am again telling you, one more time I am telling you, one more time I am telling you that whenever you see, when to apply this property, whenever you see NCR is getting multiplied with R square and sigma is there. Okay, in that case, which property is required? NCR is equals to N by R, N minus 1, CR minus 1. Okay? Alright? Yes? Clear? Chalo. Now this question, everyone, again similar type of property we are going to use. R is equals to 0 to 20. Okay? So again, 20 CR is getting multiplied with R square. Now this time R square. So since it is R square, you know what? All we have to do is R square minus R plus R. Okay, this is what we are going to do. 20 CR sigma R is equals to 0 to 20. So whenever now there is double square, no? See, if you have just R, if just R is getting multiplied, then simply directly apply the property. But whenever there is R square, you know what? You have to minus R and plus R. Okay. Why? I am going to tell you right now. Okay. So this is what R minus 1. So club them together. So this is what R minus 1, 20 CR plus R times 20 CR. Sigma is already there. Sigma is already there. Okay. Now this sigma R minus 1 is already there. 20 CR. Now, over here, I am going to apply the same property. It is going to be 20 by R, okay, and 19 CR minus 1. Now, you know what? 19 CR minus 1, I am going to apply one more time the same property. So, this will be 19 upon R minus 1 and 18 CR minus 2, okay, plus. Sigma is there. Now, here, so we have to, I told you now, whenever there is R, just apply the property right here, right now, one time. 20 by R. 19 CR minus 1. So clearly, R and R minus 1 are getting cancelled out. 20 and 19 are coming out. Sigma of 18 CR minus 2, where R is starting from 0 to 20. Okay, so 0 you can't put, 1 you can't put, but so this is what? Sigma of 18C something. Okay, so this is 20 into 19. Answer will be 20 into 19. And if you're going to put R is equals to 2, here 18C0, 18C1, 18C2. So this is what kind of expression is what you're going to get. Okay. What about this? This is cancel. 20 is coming out. So plus 20. And you know what? Again you're going to put. So this is 19C0 plus 19C1 and so on. So answer will be what? 20 into 19 and this is 2 power 18 plus 20 into 2 power 19. This is your answer. Okay? Yes, 20 into 19. So now again you can solve it. 20 if you take common. So 19, 20 also you take common, and you know what, 2 power 18 also you take common. So this is going to be 19 plus 2 power 18 is come out. So this is how it is. Yes, so 21. So 21 into 20, 420. 420 into 2 power 18. So this is matching with option D. Yes? Okie dokie? Everybody? Yes? Okay. I think now we are still left with one more question. Yes. Last question. Okay. Make sure that you attend this, because this is most easiest of all, I guess. Now I think everybody will be able to do this question. If the arithmetic mean of all the coefficients in the binomial expansion of this, arithmetic mean, what is arithmetic mean? Sum of all the coefficients upon number of coefficients. First of all, tell me, how many terms will be there in this? Okay. So please understand, x plus y power n, the total number of term is n plus 1. So number of terms over here will be 2n minus 3 plus 1. Okay, n plus 1, total number of terms. Okay, sum of all the coefficients, everybody. So we'll start with 2n minus 3, C0, 2n minus 3, C1, 2n minus 3, C2, sum of all the coefficients. Okay, all right. So now you know that sum of all the coefficients will be what? 2 power n. So 2n minus 3. This is arithmetic mean. Okay, upon this is 2n minus 2. So this is 2 power n minus 1. This is nothing but 16 as per the question. Right? This is 16. So now they are talking about the value of n. Value of n. So n can be what? Who can tell me what will be the value of n? So what shall I put the value of n? Obviously n is going to be n is going to be an odd number. Can anybody tell me what will be the value of n? You can hit and trial actually. So n will be odd number. Why? Because if you put even number over here, n minus 1, we need even now, so n will be odd. Okay. So n 5, let's put 5, let's try 5. N is equals to 5. So this is what, the moment you put n is equals to 5, 5 2s are 10, 10 minus 3 is 2 power 7. Okay, the moment you put 5. And this is 2 and 5 minus 1. So 2 into 4. So if I put n is equals to 5, what are we getting? So this is 2 power 7 and this is what? 2 cube. Yes. In fact, this is coming out as 2 power 4, which is 16. So n is equals to 5 is actually satisfying. Okay. I have randomly guessed it, by the way. You might be thinking, Ninja ma'am, first hit and trial you are happening, it is happening. You know what? I thought that 3, 5 and 7, I think these three values might get satisfied. Okay. Not sure, not sure. You guys are saying 3. Let me check. N is equals to 5. Yes. Now the moment n is 5, 5 2s are 10 minus 1. So this is 9. And this is 25 minus 20. So this is 9, 5. 9, 5 is the point and distance of 9, 5 from this. So this is 9 plus 5 minus 8. I hope you know the formula by root 2. This is the answer. So this is 9 minus 6 by root 2. If you rationalize, you are going to get 3 root 2. Option D is absolutely correct. Okie dokie. Yes. All righto. Perfecto. All right. On this note, we have actually, let me check if I have anything left out in this session. Okay. So one by, let us just summarize what all questions we have done. Okay. We still have 1 minute. So let me summarize. Term independent of x we have done. Okay. Then we have done the ratio related problems, that the ratio of the coefficients is given to you. Okay. Or you need to calculate. number of rational and irrational terms. Okay, then we did this remainder problem. Okay, and then property of summation property of binomial theorem along with ninja technique. Then we saw these type of problem. Then independent term independent of x again, ratio of coefficients again, number of rational term again, divided it, right? Yes, number of rational term again. Then we have, okay, remainder problem one more time. Then we did this question right now, and the last two questions. Yes, absolutely, we are done. Okay, 26 can be written down as 2 power 4. What are you saying, Shrija Komal? Shrija Kumar. Anyway. Yes. Okay. I think remembering easy. I am glad that you are understanding now that maths is not that tough. Okay. Some chunks are tough. Some chunks are easy also. It's a balance of both the worlds. You have to focus on your easy things. Okay. All right. So now I think we are done with today's session, and if you are liking the morning sessions now, then you have to request it. Okay. Without hit and trial, how to solve? Dare to shine. Which question are you talking about? I think I have given you all the solutions. I have given you the proper method also. Okay. So just rewatch the session. You will find that thing. Okay. Also, please understand, if you want the morning sessions to happen throughout the December. Okay. One student is coming, tell how to solve remainder problems. What I have already done that in the session. You were not there in the session. Are you joining right now? Then go and watch the video. Okay. Already done and dusted. We are leaving. Okay. See, this is how people do. This is how what students do. Okay. Whenever, I mean, ma'am, when is the obsession J series? Soon. Okay. Last question, ma'am. N is equals to 5. For that, so you have to do hit and trial only. No other option. You can't solve exponent and algebra together. So hit and trial only. Okay. Why do you want to solve the question with the longer method? Okay. And that is not an hit and trial method. That is actually something which is obvious as well, that n is going to be odd number. Okay. Alright, chalo. Bye bye. See you. I'm going to meet you. But yes, what I was telling you is you guys are distracting me. You have to request that yes, we are liking morning session. It should happen regularly next week onwards as well. So make sure that you are commenting everywhere, huh? So that we guys notice. Chalo. Bye bye.